Okay, so now our next speaker is Kirsten Westeinde. Yes, I absolutely nailed it. Warm round of applause for her, please.
It's 2016. In the decade since the launch of Shopify, our development team has grown from a single developer working on a focused problem to hundreds of developers solving a diverse set of problems across the commerce landscape. This diverse functionality, from payment processing to handling shipping to managing and installing third-party apps, was all being powered by a singular Ruby on Rails monolithic code base. And this had worked for us for a while, but recently developing in Shopify had become slower and slower. The application was extremely fragile, and new code could have quite unexpected repercussions. Making a seemingly innocuous change could trigger a cascade of unrelated test failures. Developing in Shopify was requiring a lot of context to make simple changes. So it was clear that we had outscaled our architecture and we had some difficult decisions to make. Fast forward to today, about 6 years later, and we now have thousands of developers productively working in that same monolithic code base. I'm Kirsten Westeinde, a senior development manager at Shopify, and I've been working there for 9 years, so I've gotten to see many different parts of this journey. And today I'm going to walk you through how we got from that hard place we found ourselves in 2016 to today, where we're building productively at a massive scale, thanks to our investment in good software design principles and some unconventional thinking along the way. So this is the super high-level timeline of the journey that we're going to be walking through together today. So in 2006, Shopify was founded by our CEO, Toby, who wanted to start an online store to sell snowboards. But he looked at the available options for selling online, and there weren't really any that worked for his needs. So he actually pivoted to building his own online store backend solution. And at the time, he decided to use Ruby on Rails, which was just being finalized. He actually got early access to it via an emailed zip folder from its founder. And so he worked on the solution alone for some time, but then eventually decided to bring on other developers to help accelerate that. And so 10 years later, in 2016, the Shopify application had evolved from a simple online store to a mature commerce platform that allowed people to sell in person, online. It allowed them to define complex product catalogs, manage their inventory, and much more. And so at this point, hundreds of engineers are working on it. They're building in our main Rails monolith. And at this point, it's kind of clear we're onto something. Like, we're growing in merchant count, and so it seems like we're going to be working on this for many years to come. So it seemed like the right time to invest in a re-architecture to enable us to continue to scale and to continue to add new functionality. So it was at this point that we kicked off a project which was initially called Break Core into Multiple Pieces. That's what happens when you let engineers name things. And core is how we refer to our main monolith internally, so you'll hear me say that a couple of times. And then we'll fast forward to 2018, and we'll take a look at what we learned from this initial project, how we kind of evolved where we were focusing our energy after investing 2 years in it, and also what we did a bit differently the second time around when looking at a newer code base. And then lastly, we're going to zoom forward to today, and we're going to talk about some of the benefits that we've gotten from having invested in this effort. But before we get into all of that, I want to share just a bit of background information to help contextualize all of this for everyone. Because I know we have a really diverse audience here today with different experiences. So a couple things that I want to talk about to make sure we're starting off on the same page. The first is Ruby on Rails. The second is the systems that make up the Shopify ecosystem. And the last one is what exactly I mean when I say the word monolith. So, first off, for those of you that are not familiar with Ruby on Rails, it's a full-stack framework that allows you to quickly build web applications. It abstracts away a lot of the stuff that you need. It gives you all the plumbing needed to serve web requests. And on this slide, you can see how a typical Rails application is organized. So all the code that powers your application is in this app folder, and then below that, everything's organized by software concepts. So things like models, views, controllers, jobs, etc. And all of the code that you'll find within the app folder is globally accessible to each other. meaning if you're writing code in a controllers folder, you can access code in the models folder without having to do anything to declare that dependency. So you can probably already tell how this starts to get a bit messy when you add more and more code with distinct responsibilities into that same code base. And this is a really different pattern than other languages, say like Golang, where you have to actually explicitly define dependencies on a package to be able to use the code in it at all. So it's a trade-off. Neither is necessarily right, but what this does give you is the ability to move really quickly in the beginning and to not have to worry too much about design. So it makes it easy to use, but it makes it not that hard to misuse or to fall into some bad patterns, which we'll get to. Okay, so then next up, some background information about how the systems that make up the Shopify product are designed. So this is an incredibly oversimplified picture of what it looked like in 2016. So basically, all core commerce capabilities that 100% of merchants need to run their store are built into the Shopify/Shopify or core monolithic code base. So this is things like auth, staff and permissions management, inventory catalogs. It's actually quite a long list because commerce is really complex and all of the pieces that you need to run a business are a lot. But then any capabilities that extend these kind of core commerce primitives are built as separate applications, and they use APIs, public APIs on the Shopify application to extend that functionality. And so we have a whole app ecosystem where merchants can install apps on their store to add additional functionality or remove it. And these apps are built both by first-party developers in-house and third-party developers outside of Shopify. And then the last principle to keep in mind is just that even though we like our monolith, even if there are a system that has like quite different, whether it's performance or security constraints, we do build those out as their own services so that we can kind of manage and scale them independently. So for the rest of this conversation, we're going to be mostly zooming in on the Shopify core application. But I did want to just paint this picture to say that, even while we are fans of monoliths, it is kind of happening within the greater picture of a service-oriented architecture. Okay, now the last piece before I get into the good stuff. I want to make sure we're all on the same page about what I mean when I say the word monolith, because I'm going to say it a lot. I already have. So no, I do not mean a giant slab of rock. What I'm referring to is a single code base that powers multiple distinct functionalities, but there's no boundaries between the code that powers each of those things. So if an application does a single thing, just because it's all in one code base, doesn't necessarily mean that it's a monolith. And most applications start off as monoliths. If you don't design intentionally to not be a monolith, that's what you're kind of going to organically evolve into. Especially with a language like Ruby on Rails, where nothing is stopping you from accessing code that was originally built in service of potentially a different domain. And I actually think that's an okay thing. Behind me, you'll see a visual depicting Martin Fowler's design stamina hypothesis, which is basically saying that early on in a product's lifecycle, it's almost always better to optimize for speed than for design quality. And that's because if you're not able to build enough functionality to get users, to get feedback, to find product market fit, then who cares how well designed your system is? But if all successful applications will reach a point, which is depicted as that design payoff line, where it actually does become worth investing some effort in a more intentional design that allows you to continue to scale and that allows you to continue to move quickly. Now, I've given similar presentations to this one a couple times before, and the two questions that I always get are, how do you know when you're at that design payoff line? And then once you are there, how do you convince the business that it's worth investing so much effort into a refactor? Now, I wish very, very badly that I could just give you an easy answer to those questions. But the reality is that they're both pretty dependent on your unique business and application context. So there isn't really a one-size-fits-all answer. And there are trade-offs to doing this design both too early and too late. If you do it too early, it could mean taking away valuable resources from building product that could make or break your business. It could also result in you getting the design wrong because you don't yet know enough about the end state of your application as you're continuing to make pretty significant business pivots early on. But similarly, there's trade-offs to doing it too late. The more code your application has, the harder it's going to be to refactor. As a general rule of thumb, it's riskier and harder the later in the game that you try to embark on these types of things. So I know that paints a dark and pessimistic picture, but I will say there are a couple of things that you can look out for to hint that you're probably in the zone of needing to do something. The first big one is a slowdown in how long it takes to build functionality of similar complexity. It can be a hard thing to get a pulse on, but if your organization uses story points or velocity, that can be one signal of a downward trajectory in how long things are taking to build. Sometimes you might just have to rely on the intuition of developers or product managers who have been there for a long time and who have a good sense for how long things used to take versus currently take. And this slowdown can be a symptom of a bunch of different things that result from lacking a good system design. The first is that to add new functionality, you might have to do a bunch of refactoring first up front to be able to even get started on it. And the second is that when you add new functionality, it might break tests unexpectedly, and it's not always obvious why, and it takes some time to debug. The second thing to look out for is a decline in developer experience. Well-designed code bases are fun to work in, and productive developers are happy developers. One key input that prompted us at Shopify to kick off this initiative was a downward trend in our annual developer happiness survey. Another thing that you might start seeing is an increase in downtime or incidents. And this could be because the code is so hard to test that developers just start skipping it. It could also be because if you're writing code in one domain and validating those changes in one domain, but it has an unexpected repercussion in another, you might not think to validate that domain before releasing. And then the last thing to look out for is a slowdown in onboarding new developers. Because the easier it is to navigate and understand your code base, that can be like a sign that it is well designed. So if your company measures things like time to first PR, time to 10th PR, whatever that is, that could be a good data point as well to keep track of. In 2016, for us, this was another really big sign where new developers coming on were needing to take in a ton of information before being able to even ship their first PR. For example, if we had a developer starting on the shipping team, theoretically, they should only need to understand the implementation details of the shipping business domain. But the reality was that they also had to understand how and when orders were created, when we started fulfilling them, how we processed payments, and so many more things, which is just too much for one person to hold in their head just to ship their first PR. Complex monolithic applications result in steep learning curves. Is this sounding familiar to anyone? If you are in this situation, which many people and companies that I have talked to over the years do find themselves in eventually, so you know you have a problem and you want to fix it, the next question is, how do you convince the business to do so? And to be honest, that's one of the harder parts. At Shopify, we're lucky to have an engineer as our CEO, so investing in technical initiatives might be a little bit easier than at other companies, but we do still have to take the time to kind of justify why we're asking to put all of these resources towards this effort versus something else. So we took the time to document a case for how much effort we thought this would be, what the benefits we would get out of it, the risks of not doing so now, and as much data as you can bring into the picture as possible, the better. And we're also in the lucky position at this point in time that we did have hundreds of engineers working on Shopify, so we could divert some resources towards this without grinding product development to a complete standstill, which made it an easier sell. Now, talking about how to convince the business to do this is a whole talk in and of itself, and there actually is a talk about this tomorrow on this stage around 4:40, so if you want to think more deeply about this topic, I would suggest watching that. So now we're at the point where we know we have a problem, we have buy-in to invest energy into fixing it, and now we have to figure out what to actually do about this problem. So we wanted to be data-informed when coming up with a solution, so that we were solving the real root problems, not just the ones that were being anecdotally reported. So one thing we did was send out a survey to all of the developers working in this core system to kind of try and understand all of the different pain points that they were dealing with. And pretty much every single thing that we heard could be traced back to the lack of boundaries between the distinct functionalities in our code base. We were sitting squarely in this monolithic big ball of mud category. So the results of that survey informed the decision to split up our code base. Now, the popular solution at the time for increasing modularity is to adopt microservices. And I think probably you all know what microservices are, but in case you don't, it's like one application that's powered by a suite of smaller services that are all deployed independently and have singular responsibilities. And as we started researching for this project, it felt like every single place we looked was touting microservices as the be-all, end-all solution to these problems. And it is true that microservices would have solved all of our modularity problems, and they are an excellent tool in some situations. But we came to the conclusion that it wasn't the right solution for us, and that's because it would bring with them another set of trade-offs that we didn't really want to take on. The thing is, even though the lack of modularity in our monolith was causing us some pretty serious problems, there was still a lot that we loved about this architecture. Maintaining the entire code base and deploying it to one place has a ton of advantages. You only have to maintain one repository. You can quickly search across it to find all of your code. You only have to maintain one test and deployment pipeline, which, depending on the complexity of your application, can save a lot of overhead. Because they can be expensive to create, to customize, and to maintain, and it takes a concerted effort to maintain consistency across all of the different applications. And also, because the code lived in one place and was deployed to one place, all of the data could just live in a shared database. And you could have performant database queries to get access to the data that you needed rather than having to make network calls to get it. And it also means only managing one set of infrastructure. The average Ruby on Rails application comes with, at minimum, a database, a web server, background jobs capabilities, but more often than not, it comes with even more things like Redis, Kafka events, Elasticsearch, potentially much more. So every additional set of infrastructure that you're adding into your system increases the amount of time that you're going to have to spend with your DevOps hat on and decreases the amount of time that you can spend building. Additional infrastructure also increases the possible points of failure, which can decrease your application's overall security and resiliency. And one of the most compelling benefits, to me at least personally, is that when things are split out over multiple services, you have to worry about backwards compatibility and API versioning between those systems. Whereas when it's all in one place, you can just change both the caller and callee in one PR and call it a day. So we weren't yet ready to give up on all of these benefits of monoliths. And in this case, I'm really happy that we put on our critical thinking hat and really analyzed whether the solution was right for our specific problem and our context, before just cargo culting what the popular solution was. This was not the first time that Shopify's rebel, non-conforming spirit helped us make a better decision for us, and it definitely was not the last. At one point in my career at Shopify, I briefly worked on a microservices application that we inherited through an acquisition. It was a really cool product. It was a machine learning-powered recommendation engine that served up tailored and actionable marketing campaigns for our merchants, so they could just say yes, and we'd go ahead and create the campaigns on Facebook, Instagram, or Google. And even though we were solving a really cool problem and a really impactful product, it actually just wasn't really that fun to work on. And that was mostly because of the coordination overhead required to deploy changes to 13 different applications to change the behavior. It also meant that if there were security incidents or dependency upgrades that we had to do that in 13 different places instead of one. Now, I will admit that application had other design problems beyond just using microservices, but microservices did exacerbate some of those problems. So instead of moving towards microservices, the solution we landed on was a middle ground that allowed us to keep the benefits that we loved of our monolith and also incorporating some of the benefits of that high modularity of microservices. So we decided to go from this monolithic big ball of mud category to a modular monolith. So it's still a monolith in the sense that all of the distinct functionality is in one code base and deployed to one place, but it's modular in the sense that boundaries are set up and enforced between these different domains. In early 2017, a small but mighty team set out to do this. The project was initially called Break Core Up into multiple pieces, but it eventually evolved to be called componentization. Components are how we refer to the modular units that encapsulates a single business domain. In thinking about how to tackle this project, we wanted to first start with a set of principles or things that we were optimizing for to achieve. The first is that we could not block developers from adding new capabilities to the system. So any solution that required a code freeze, even if it was just for a couple days or weeks, was off the table. The second was that we knew that this was going to be a big undertaking and we were going to be working on it for a long time. So designing for that interim state was just as important to us as designing for that end state. Delivering value incrementally was going to be a key to succeeding here. And the last thing was that rather than trying to do all this work ourselves as a project team, we wanted to optimize for influencing all of the developers across the company to buy into this vision and help make us happen. And we actually needed their help because they were the subject matter experts in these domains, and we really couldn't do it without that buy-in. So this meant focusing on defining best practices that made patterns easy to adopt and tooling that made progress easy to measure. With all these things in mind, we kind of broke the project down into 3 main phases. The first phase was going to be reorganizing our code. The second one would be then isolating dependencies between those components, and the last one would be enforcing boundaries between them. So remember, at this point in time, our code is organized by software concepts, so it's grouped by models, views, controllers, etc. We wanted to evolve this to be organized by business domains. And we figured business domains was the right layer of abstraction here for a couple of reasons. One is that if by grouping code that performs similar tasks together, we're achieving high cohesion and high change locality, meaning that code that changes together frequently would be encapsulated together. Because we wanted to optimize for changes to be contained to a single component most of the time. There definitely are some times where you need to make cross-component changes, but we wanted that to be the exception rather than the rule. And lastly, we wanted to map owners to each of these components, and our teams are organized around business domains. We've gone through many different evolutions of our org structure over the years as we've scaled, but the one thing that has remained mostly constant is that we do define teams around products. We have some horizontal teams that are exceptions to this rule, but the majority of our developers work within a team that solves a specific set of problems for a specific set of users. And those users can be merchants, buyers, partners, or internal teams. So once we had this plan, we had to actually come up with a list of what those components should be. And that required talking to a lot of people. We basically had to connect with stakeholders in each different pocket of the organization to get their opinion on what the right business domains were. And then once we had that list, we had to actually decide where all of our existing code belonged. So we had about 6,000 Ruby classes at this point in time, and we wrote up a giant spreadsheet, and we listed every single class in that spreadsheet and manually assigned each class to a component based on where we thought it belonged. We then achieved this move in one big bang PR that was built by automated scripts based off of this spreadsheet. Even though no code actually was changing in this process, it still touched literally every single file in the code base, so it was potentially very risky if done incorrectly. The types of failures that would result from these changes would be our code not being able to find object definitions, which would result in runtime errors. And because our code is well tested, we were able to get some confidence by running our test suite locally in CI, and then also just running through as much functionality as we could, both locally and on staging. And we were actually able to ensure that nothing was missed. And that's a key point, really. Before you embark on any large refactoring journey, you're going to want to make sure that you have good test coverage to have your back through the process. We chose to do it all in one PR rather than a few smaller PRs to minimize the disruption to the rest of the developers. While it was potentially riskier, it meant that devs only had to do complex rebases for their open PRs once, rather than a bunch of times as we made these moves. One unfortunate downside of doing it this way is that we actually lost a lot of our history in GitHub because a lot of these file renames were incorrectly tracked as deletions and then additions. And so we can still get the history using the git follow option, but the GitHub UI does not recognize that, so unfortunately it's a bit harder to track down history from before these moves. And so this was the end result. You can see the top level folder is components instead of app, and then within that, you can see some examples of some of the components that we landed on. So things like taxes, billing, checkouts, etc. So now that our code was organized by business domain, and that was great, but we actually hadn't done anything yet about the amount of interdependency between each of these domains, which was the next problem that we solved. So the plan was for each component to define a clean, dedicated interface with domain boundaries expressed through a public API. Each component took exclusive ownership of its associated data, and other components could only access it through its public API. Now, the project team couldn't achieve this for the whole organization because it required expertise from each business domain to actually get that API right. So instead, what we did was we defined some patterns, and then we partnered directly with one or two teams to build this out in their domain to provide other examples that the other teams could base their work off of. And then we also built out a tool called Wedge to help complete this task. Wedge tracked the progress of each component towards its goal of isolation. It highlighted any violations of domain boundaries and data coupling across those boundaries. To achieve this, we wrote a tool to hook into Ruby trace points during CI to get a full call graph. We then sorted all of the calls that were called during testing by caller and callee, and we selected only the things that were across component boundaries and sent those off to Wedge. Along with these calls, we sent along some additional data from code analysis, like active record associations, and sent those along as well. So Wedge would then take a look at all of those things and determine which one of them were violating and which ones were fine. Generally speaking, model associations across component boundaries are violating. And calls are fine as long as they're going through the public APIs. So Wedge would then compute an overall score per component, and it would also list out individually, if you clicked into a component, every single violation within that component. So we use these progress scores to inspire some fun and nerdy competition across all of the different dev teams. The engineering leadership team helped us to prioritize this company-wide initiative by making sure to always shine a spotlight on it at our all hands, and also celebrating and incentivizing the progress of each team. Now, the original plan was to take this one step further and enforce these boundaries programmatically. The high-level approach would have been for each component to explicitly state the other components that it had a dependency on and only load those components, which would result in runtime errors if they tried to use code in any of the components that they didn't define dependencies on. And similarly, we could trigger runtime errors or test failures if the components were accessed through anything other than their public API. But given the approach that we chose of first reorganizing the code before starting to isolate dependencies, meant that we couldn't actually enforce these boundaries before all the components were fully isolated and there were no more violations left. And unfortunately, after about 2 years of work on this project, we still weren't there. The momentum we'd originally had going was difficult to maintain, and not all teams were able to continue to prioritize this tech debt against their product roadmaps. We were also continuing to hire at a rapid pace, and it was hard to maintain that same level of understanding and buy-in as the team was growing so quickly. The codebase was littered with both good examples and bad examples, but without consistency, it made it hard for developers to know which one was the best practice and which one they should be sticking to. So at this point, the project team decided to take a step back and reevaluate where we should be focusing our energy. And we landed on 3 main things. The first was doubling down on evangelizing this initiative. The second was taking a look at our dependency graph and disentangling it where it made sense. And the last one was building better tooling. So far, we've been mainly focusing on the technical aspects of this problem, but upon reflection, it was clear that making a fundamental change to a system that is being actively worked on like this is, in equal parts, if not more, a people problem. We needed to focus more on changing developer behavior. A lot of the patterns that we had introduced so far were actually adding friction to developers' lives, and they weren't really making them that desirable or easy to adopt. So we moved in a direction of having increased flexibility and less hard and fast rules, because we needed to make their lives easier, not harder, if they were going to buy in and adopt this. We needed to help this be a part of the path of least resistance. On the education front, we gave internal talks at our weekly company-wide dev talks. We also added documentation to the development handbook with examples. We made sure to share and amplify any wins that were coming out of individual teams. And then we actually embedded within a couple product teams for some extended periods of time and paired with people all over the company. We also leveraged the recently formed architecture guild at Shopify to garner support from like-minded individuals. And then the next thing we did was we took a look at our dependency graph. So up until this point, we'd been really focused on the access patterns between components, but we hadn't really zoomed out and taken a look at the bigger picture of how all of the components fit together and were coupled together. When we did, we unsurprisingly found that we had a really dense dependency graph that had a lot of circular dependencies within it. As with all applications, we had one central entity that almost all of the other components depend on, and for us, that's the shop class. So we decided to move in a direction where the shop identity component had very little concrete implementation and rather was a shell container holding only the identity of a shop and some abstract concepts. And this was the first step towards differentiating between 3 different types of components. The first one are platform components, which purely provide functionality to other components and shouldn't depend on any other components themselves. They'll just be depended on. And then the next one is supporting components, which leverage stuff that's defined in platform components, but also serve up some of their own functionality, both to the front-end components, which serve up UI, and externally, sometimes through APIs. And then the last thing we did was we leveraged inversion of control to break circular dependencies. So you can see an example here between the online store and the merchandising component, where instead of having method calls going in both directions, we would have method calls going in one direction, and then we'd use a publish-subscribe mechanism to, in the other direction, inform the component that something interesting had happened, and then they could call back into that component. So we did this using active support notifications, but you can really use any publish-subscribe mechanism to achieve the same thing. And then the last thing we did was we deprecated Wedge, and we introduced a new tool called Packwork. With Wedge, we were finding that the results that were being produced were often not super useful. Call graph logging produces a lot of data, and we were finding it hard to differentiate between signal and noise. Also, because this analysis depended on the full test suite being run with some added instrumentation, it was taking over an hour to run, which just wasn't providing a helpful feedback loop. So we developed a new tool called Packwork, which analyzes static constant references. There's less ambiguity in static references, and also because they're always being explicitly added by developers, it's more actionable to show these violations to developers. And Packwork's able to run a full analysis of our largest code base in a few minutes. So we're able to include it in our pull request workflow, and you can also run the check locally on your machine before even pushing up your PR. This allows us to reject any changes that break the dependency graph or component encapsulation before they're merged into the main branch. Packwork is now actually open source, so I'm going to share a quick demo video, hopefully it will work, from my colleague Maple. Are we able to get audio from the video? No, okay. They're giving me shakes of their heads. Okay, well, basically the main takeaway here is that each component it's okay, I can explain it. It's only a 1-minute video, so I can explain it. But I'll share the link later, perhaps, to that video. But basically, how it works is each component it has a package.yaml file where it defines the other components that it has a dependency on. And it only can access code in that component. So if it tries to access code in another component, that violation will be automatically logged to a file, an append-only file that tracks violations. And similarly, if it calls code in a component that it does depend on, but that's not in its public API, that violation will also be logged. And so this allows you to enforce boundaries and ensure that no new violations are being introduced, even if you're in an in-between state where some already known violations exist, which is really helpful. So around this point in time, we were writing the first few lines of code for the Shopify Fulfillment Network application, which is the product that I work on today. The Shopify Fulfillment Network, or SFN for short, allows merchants to offload all of their fulfillment responsibilities to a Shopify-powered network of warehouses that offers 2-day fulfillment, easy returns, and much more. Since this is an add-on feature that's not core to commerce and not all merchants use, it was built as a separate application that can be installed on Merchant Store as an app. When we were about a year into this project, we decided to take some of the learnings from Shopify Core's componentization project to ensure that we had good boundaries between domains from early on. So instead of first reorganizing our code and then trying to isolate dependencies and enforce boundaries, as the core team had struggled to do, we actually started by enforcing boundaries right away. So we mounted each component as a Rails engine and used Packwork to enforce dependencies between them. And then as we moved code out of the main app folder and into these component folders, we'd refactor it such that all of the code within the component folders was following the rules. The main difference between this approach and the one taken by the Shopify core application is that we decided to prioritize for having boundaries early on rather than having well-defined ownership early on. So some code was still living in the app folder without clear ownership. But that was the right trade-off for this team at the time because there were way fewer developers working in it, and it was also a more fluid team structure, so that clearly defined ownership was less important early on. But since then, we've made a lot of progress moving code over into the component files, and we now actually are getting the ownership benefits as well, which is convenient because the team has grown a lot and we are a lot more structured these days. One of the nice things about doing it this way is that when you are in that in-between state where you have started but not finished the componentization of it, all of the code within the component folders is following the rules, which means new developers and old developers have consistent examples to follow and they know what the best patterns are. And everything that's in the app folder, everyone knows we want to abstract it and not to follow any of the patterns that are there. And because of the way that the Packwork tool works, we basically have a list of tech debt to chip away at to finish this project. And that list is that file that lists all of the violations. So PRs would fail CI if any new code was added into the app folder or if any of these component violations were introduced, which works a lot better than relying on developers to try and catch them during PR reviews because humans are prone to errors in a way that software is not. So when thinking about the right solution for your code base or your team, think about which is more important, whether it's ownership early on or boundaries early on, because you will probably be in that in-between state for longer than you might expect. So I'm not going to claim that either of these two solutions are perfect. They both have trade-offs and downsides, but I will say that we've gotten a lot of benefits from having invested in this effort. If I had to boil the benefits down to a single point, it would be that componentizing our code base allows developers to feel like they're working in a much smaller code base than they actually are. In this model, making onboarding plans becomes easier. You just have to learn your own component in depth and learn about the public APIs of the components you depend on. And you don't even have to worry about any of the other components. Since the only contract that a component has with the outside world is its public API, teams can move quickly and add new functionality or even do large refactors within their component so long as that API remains standard. And if it does need to change, because all of the code's being deployed to a single place, you can change both the callers and the API at the same time. And because of the isolated nature of components and the fact that the majority of developers' time is spent in a single component, the teams that own them can actually define their own standards and best practices for each component. One example is when we added Sorbet, a static type checker, to our component, and one team actually was the one driving this initiative. They wanted to experiment with it within their own component. They learned how to use it, they validated that the benefits outweighed the effort, and then we decided to invest in this across the whole code base. And doing these cross code base sweeping technical initiatives is way easier now that we do have programmatically defined ownership. Because we can just automatically create issues or pull requests and assign them to the teams that own those components. And this is actually how we keep our code base up to date on the latest versions of Ruby and Rails as well. This programmatically defined ownership also made our on-call and issue triaging process so much better. All issues that come in are automatically assigned to a team-specific bug snag project or Slack channel or PagerDuty rotation. So any errors that you're seeing are relevant to your team and actionable, rather than having to look at the very noisy exception stream of the entire monolith. And lastly, having isolated components with clearly defined boundaries has made it significantly easier to extract components out into their own services, if that makes sense to do. It would be as easy as evolving the calls to the public API, which are now just method calls, into network calls. Because all of the communication into and out of that component are going through these public APIs, that should be the only layer where anything needs to change. So if you are still gung-ho on microservices, first modularizing your monolith can be a good incremental step to take on your way there. And lastly, investing in these efforts have unlocked our ability to reach a massive scale, both in terms of the number of developers working on the code base and handling requests for millions of merchants and buyers. I can almost guarantee that none of this would have been possible had we stuck to our original monolithic architecture. So while we have made lots of progress, this effort is by no means over, and to be honest, it probably never will be, because good software design is a constantly moving target. You always know the most about your problem space right now, and new ideas and new tooling will always be emerging. But in conclusion, I'd like to ask you to consider, if you are outgrowing your monolith, looking at first modularizing it before jumping straight to microservices to allow you to keep all of the benefits of monoliths while also getting those high modularity benefits from microservices as well. And if solving problems like the ones that I've discussed today are of interest to you, Shopify is hiring a lot in Europe, so feel free to reach out or check out our careers page. And that is all from me. Thank you for listening. Woo!
We have time for questions. Here's your free alcohol.
Thank you.
We have 1 minute, 20 seconds. First question, Kirsten, comes from Anonymous. How would you ensure high test coverage on a legacy monolithic ball of mud?
Yes, it gets harder and harder the farther into that monolithic ball of mud that you go. I think one of the big signals that you're outgrowing that architecture is when adding tests becomes more difficult. So that can often be, you don't want to go so far into the direction of a monolithic big ball of mud where you're not able to add those tests. But similar like test-driven development practices work well for monoliths in the early days.
Anonymous again with, have you considered moving away from Ruby on Rails? It sounds like most of the problems stem from it allowing too much flexibility and dynamic behavior.
It's a good question, and it is true that some of these problems are unique to Rails, but a lot of them aren't necessarily unique to Rails. And so we've actually kind of taken a different approach. Rather than considering moving away from Ruby on Rails, we actually have a full team of in-house developers that are contributors to Rails core. Because Shopify is one of the largest applications using Ruby on Rails, we tend to be the ones to kind of find those boundaries first. And so we are contributing directly back to the language to help evolve it into something that can serve the needs of massive code bases like ours and others.
Thank you very much. If the other people, are they allowed to come and accost you for questions? Yes.
Absolutely. I'll be over here.
You can come down the front here and accost for questions. Everybody else, it's break time. We will be back in 10 minutes.